Right now I'm going to work through the solutions for page 12 through 14 of the workbook. If you're just looking to check your work, you can look at the answer key. This is more for if you need video, verbal explanation as to why the answers are what they are. And for some reason, I'm not with you to answer your question. So you're doing it at home or I'm not in class. So this first section is simplifying radicals. You'll need your calculator for this. If I want to simplify the square root of 500, the first thing I would do is check to see if it's a perfect square in the home screen of the calculator. So second x squared root 500, but that's a decimal. So what I would do next is I would go to the y equals screen, and I would do 500 divided by x. What I'm looking for in the y equals screen, specifically in the y1 column, is I'm looking for a perfect square. And you should know your perfect square. So as I go down this list, my highest perfect square is 100, and next to the 100 is a 5. So I'm going to split. So as I go down this list, I see 500, 250, 125, 100 is the first perfect square I hit. So, and next to 100 is a 5. So I am going to simplify the square root of 100 to 10 and keep the root 5 the same. So I get 10 root 5. I'm going to do the same thing for the next one. 108 isn't a perfect square, so I'm going to do 108 divided by x, and I'm going to go down the list. 108 isn't a perfect square, 54 isn't a perfect square, but 36 is. And in the table next to 36 is a 3. That coefficient of negative 6 just stays in the front. So this problem becomes negative 6 times 6 root 3, or negative 36 root 3. We're just looking for perfect squares here. For number 5, I'm going to combine the numbers in front. 5 times 9 is 45. And then I'm going to combine the numbers in the root. 6 times 3 is 18. 18 itself isn't a perfect square, but if I do 18 divided by x and I go down the list, 18 is not a perfect square, but 9 is. And next to 9 is a 2. And then I'm just going to keep the 45 the same. So this problem ultimately becomes 45 times 3, root 2, and 45 times 3 is 135. So my answer would be 135, root 2. Multiply the numbers in front. 3 times 5 is 15. Multiply the numbers underneath. 7 times 7 is 49. Well, the square root of 49 is just 7. So this problem ultimately becomes 15 times 7, or 105. We know we can't have roots in the bottom, and if we do have roots in the bottom, we have to rationalize, which means we multiply the top and bottom by whatever root is in the bottom. Well, 13 times 8 is going to become root 104, and root 8 times root 8 is root 64, which is just 8. Now I want to simplify the square root of 104. So I'm doing 104 divided by x, and I'm going down the list until I find the highest perfect square that goes into 104, which is 4 and 26. It doesn't look like a 26. And so I end up with 2 root 26 over 8. And then I'm just going to combine the 2 8s to make that a 1/4. So root 26 over 4 is my final answer. I can't have a root in the bottom, so I'm going to multiply the top and bottom by root 5. I can't combine the 10 and the root 5. They're not like terms, so I'm just going to write that as 10 root 5. And root 5 times root 5 is root 25, which is just 5. And then simplify 10/5, and that's 2. So my final answer is 2 root 5. Rationalize the denominator here by multiplying the top and bottom by root 5. 12 times 5 is 60, and root 5 times root 5 is root 25, or just 5. I want to simplify the square root of 60, so I'm doing 60 divided by x, and I'm looking for the highest perfect square that goes into 60. And that ends up being 4. And next one's 15. So I've got 2 root 15 over 5. My like terms of 2 and 5 don't reduce for this one, so I'll leave that as is. Multiply the bottom and top by the square root of 12. 30 times 12 is the square root of 360. Root 12 times root 12 is root 144, or just 12. If I do 360 divided by x, and I look for the highest perfect square that goes into 360, I'm going down the list. I eventually hit 36 and 10. Or 6 root 10 over 12. And if I reduce 6/12, that's 1/2. I don't have to write the 1. So root 10 over 2 would be my final answer there. These next ones I'm going to have to multiply by what's called the conjugate. So I'm going to keep the first number the same and the second number the same. I'm just going to change the symbol to the opposite. So I'm multiplying the top and bottom by 3 minus root 5. So 6 times 3 minus 6 root 5. 6 times root 5 is 6 root 5. On the bottom, 3 times 3 minus 3 root 5 plus 3 root 5 minus root 5 times root 5, which is root 25. So on the bottom, what that simplifies to, these cancel out, and I end up with 9 minus 5, because the square root of 25 is 5, or 4. Sorry, that top got messed up when I wrote it out. The top should stay the same at this part. So it's 18 minus 6 root 5. Now, because all of these numbers are even, I can reduce them by 2. So 9 minus 3 root 5 over 2 would be my final simplified answer. I'm going to multiply this one by the conjugate, so I'm going to keep the 2 and I'm going to keep the root 3. I'm just going to change the minus to a plus. And I've got to do that to the top as well. So 4 times 2 is 8 plus 4 root 3. And on the bottom, 2 times 2 is 4, minus 2 root 3, plus 2 root 3, minus root 3 times root 3, which is root 9. So I have 8 plus 4 root 3, and then on the bottom, these middle terms cancel out, and I have 4 minus the square root of 9, which is 3. So 4 minus 3, which is 1. And anything divided by 1 just stays the same. So I don't need to write the divided by 1 part. Okay? So multiplying by the conjugate. That's section 1 of the test review. Moving on. Find the missing side. Express your answer in simplest radical form. Well, I have a right triangle, and it looks like for all of these I have 2 out of the 3 sides, which means I can use Pythagorean theorem. A squared plus b squared equals c squared, where c squared is the biggest, the hypotenuse. So for this first one, I'm going to do 20 squared plus 20 squared equals y is in the hypotenuse spot. So just to kind of save myself some space, I'm just going to do 20 squared plus 20 squared in one step. Well, 20 squared is 400, so I end up with 800 equals y squared. So the square root of 800 equals y. I'm going to see if I can simplify that. So I'm going to do 800 divided by x, and I'm looking for a perfect square that goes into 800. 400 is a perfect square, so I can do root 400 root 2 equals y, or 20 root 2. Thank you so much. Thank you. Have a wonderful one too.
Thank you. You're the best. You're the same.
So we end up with 20 root 2 here. And it's so which means this must have been a 45, 45, 90 triangle, but I wouldn't have known that. I didn't have enough information for that. I had to use Pythagorean theorem. Actually, I do have enough information if there's any. All right, moving on to the next one. I am going to use Pythagorean theorem because I have 2 out of the 3 legs of the triangle. Because I have the hypotenuse leg though, I'm gonna do 5 squared plus m squared equals the hypotenuse squared. Alright, so 100 minus 25 is gonna be my m squared. I'm just skipping some steps because of space. So I end up with 75. So m equals the square root of 75, which I can break up into 25 and 3. So this is 5 root 3. You also, because you know the hypotenuse is double that small leg, you also could use the 30, 60, 90 rules. Alright, final one. If I have 2 of the 3 legs of the right triangle, I can do Pythagorean theorem. You can type this all in your calculator in one step. Just put parentheses around that. So I can do like 9 squared plus parenthesis 21 root 3 squared, as long as that 21 root 3 is in parentheses. So I end up with 1404 equals x squared. So x is going to be the square root of that. And I just want to see if that simplifies. So I'm going to do 1404 divided by x. And I'm looking for a perfect square in my y1 column. I'm just going down my list here and seeing if I'm finding any. So far, 36. So I hit 36. 36 and 39. So this is 6 root 30. This whole section, if you have 2 of the 3 legs of a triangle, then that means that you can use the Pythagorean theorem. Alright, next section says, use the information to solve. Well, they're all right triangles, but they're not special rights, meaning that I'm going to use SOHCAHTOA here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So I've got this side length, I've got the hypotenuse and the side length opposite of it. And so if I have opposite and hypotenuse, I'm going to use the sine of the angle is equal to the opposite leg over the hypotenuse leg. If I were to create a proportion from this and cross multiply that proportion, I would end up with x sine of 19 equals 26. And if I would want to get the x by itself, I would divide both sides by the sine of 19. So ultimately I'm doing 26 divided by the sine of 19. You want to just make sure you're in degree mode in your calculator. That could be causing error if you're not in the degree mode. So if you hit the mode button and change to degree. So we end up with the hypotenuse leg being 79.86. All right, next one. I've got my angle, I've got opposite, and I've got adjacent. I don't have across from the 90, so I don't have the hypotenuse. I have the opposite and the adjacent, which means I'm working with tangent. So tangent is the opposite leg over the adjacent leg. If you are solving for the angle, you're going to use the inverse button in your calculator. So to do this, I'm going to do second tan of 31 divided by 50. And that would give me the angle x. So x is equal to 31.798. So I'm just going to round it to 8 degrees. All right, for the next one here, I've got opposite and I've got the hypotenuse. So it looks like I'm working with the sine of my angle, and my sine is equal to the opposite side over the hypotenuse side. And if we're trying to get an angle, then we use the inverse. So you'll hit second sine, and you'll do 30 divided by 40. Again, just make sure you're in the degree mode in your calculator. If you're consistently getting these answers wrong, it's probably because you're not in the right mode in your calculator. When you type that in your calculator, you end up with 48.59 degrees. Last one here, we've got opposite of the 90 degrees, so we have the hypotenuse, and we've got next to, so we have the adjacent. which means we're working with the cosine, and we have the angle, so it's the cosine of 70 is equal to the adjacent over the hypotenuse. I could create a proportion here, and when I cross multiply, I get x equals 8 times the cosine of 70. So all I have to do is type that into my calculator, 8 cosine of 70, and I get my side length, 2.74 if you round. Right, all of this is SOHCAHTOA. We use these when we have right triangles, but not special right triangles. All right, so I'm given information about sine, which means I have to be working with a right triangle. And I'm going to label this bottom angle theta, just because that's how we were doing it in class. It really doesn't matter which one you label theta. And sine is giving me the opposite and the hypotenuse. So the opposite leg from the angle I labeled is this one, and the hypotenuse is this one. If I want to find that remaining side length, I can use Pythagorean theorem. So as when I subtract 4 from 9, I end up with x squared equals 5, or x equals the square root of 5. So this remaining leg is the square root of 5. Okay, so I know that the sine is 2 over 3. So its reciprocal function, which is cosecant, directly opposite of it, is the reciprocal, which means I'm just flipping the fraction, 3 over 2. Cosine is adjacent over hypotenuse. So according to my angle, the next two leg is root 5, and the hypotenuse is 3. And if I go over to the reciprocal function and flip that, I end up with something that I have to rationalize. So I'm going to multiply the top and bottom by root 5. So I end up with 3 root 5 over 5. Tangent is opposite over adjacent, which leaves me with something I have to rationalize. So I end up with 2 root 5 over 5. And then instead of flipping that, I'm going to flip the original, which is 2 over root 5, to get the reciprocal, which is root 5 over 2. To get the theta, I could use sine, cosine, or tangent, but sine is the most simple of all three of those, so I'm going to do the sine inverse of 2 divided by 3 in my calculator. I just have to make sure that I am in degree mode when I'm doing that. So I'm hitting second sine, and 2 divided by 3 is giving me 41.81 degrees. Same idea for this next problem. I'm going to create my right triangle. I'm going to make it look the same as the previous one, with theta being this angle. And now I'm given the tan, which is opposite over adjacent. So the opposite leg is 10, and the adjacent leg is 3. Which means I can solve for the hypotenuse doing the 2 side lengths squared. So we get 109 equals x squared, or the square root of 109 equals x. I'm just going to see if that simplifies. So I'm going to go to my y equals screen and do 109 divided by x, and just look through my y1 for any perfect squares. I don't think I'm going to find any, but I'm just going to double check. Nope, there aren't any, so that means that my hypotenuse is just the square root of 109. So sine is the opposite leg over the hypotenuse leg. And cosecant is flipping that, so I'm just going to flip it before I rationalize. But I do have to rationalize the sine, because I can't have the root 109 in the bottom, so I'm multiplying the top and bottom by root 109. So I end up with 10 root 109 over 109. For the cosine, that's adjacent over hypotenuse. And again, I'm just going to go over to my reciprocal one and flip that before I rationalize. So I don't have to rationalize that one. And now I'm going to rationalize this one by multiplying by my root 109. So 3 root 109 over 109. Finally, tangent is opposite over adjacent, and then I can flip that to 3 over 10. I can use sine, cosine, or tangent to find theta, but tangent looks the easiest. So I'm going to do the tangent inverse of 10 divided by 3. Make sure you are in degree mode, 73.3 degrees. All right. I'm going to draw another right triangle for this one, same idea. I'm going to put the theta in this corner. I'm given the secant is 13/12. I don't really know much about secant, but I know that I can go over to cosine and say that that's 12/13, which means I have the adjacent leg and the hypotenuse leg. And so I can solve for the other leg. So 12 squared plus x squared equals 13 squared. And as I work through Pythagorean theorem, just for space sake, 13 squared minus 12 squared is 25. So x squared equals 25. X equals 5. So that remaining side length is 5. Sine is opposite over hypotenuse. And then cosecant is just flipping that. Tan is opposite over adjacent, and cotan is just flipping that. Any of these trig functions will be easy to do. So I could do sine inverse of 5/13. I could do cosine inverse of 12/13. Or I could do tan inverse of 5/12. I'm going to go with cosine since that was the one I got from the given information. So I'm going to do the cosine inverse of 12/13. But if you check them all, you're going to get the same answer for all of them, which is 26.2 degrees. All right, this next section here is special right triangles. We've got a 45, 45, 90. The side lengths are x, x, and the hypotenuse is x root 2. So I've got opposite of the 45, which is 3. So opposite of the 45 has to be 3. And the hypotenuse is 3 root 2. Side length times root 2. All right, this is the 30, 60, 90. These are based off the 30-degree leg, but I don't have that. The hypotenuse, though, is double the 30-degree leg, so I know that the short leg of the triangle is half of 4. So it's going to be 4 divided by 2. So x is 2. And then the 60-degree side length is the short leg times root 3. So this side length is going to be 2 root 3. Finally, if you have the 60-degree side length, then you have the x root 3 side. And so this one we're going to have to do a little bit of work to solve for x. We're going to divide by root 3. So the short side length is 15 over root 3, which we have to rationalize. So we get 15 root 3 over 3, or 5 root 3. So the small side length across from the 30-degree angle is 5 root 3. And then the hypotenuse is double that. So it's 5 root 3 times 2, or 10 root 3. So this one would be 5 root 3, and this one would be 10 root 3. Looks like there are a few more special rights in this section. All right, so this is a 30, 60, 90. They're based on the small leg, so opposite of the 30 is my x. My hypotenuse is that times 2. And my 60-degree side length is that side length times root 3. So this side length would be 15 root 3, and this one would be 30. 45, 45, 90. Well, I know that this is going to be my short side length times root 2, which must mean my short side lengths are 10, because I already have the root 2 spot. So these are 10. This is my 30. So I already have my short leg. So my hypotenuse is my short leg times 2. So that must be 6 root 3. And my 60-degree leg is my short leg times root 3. So I get 3 times 3, which is 9. This one is a 30, 60, 90. So I'm gonna go, I'm given my 60 leg, and my 60 legs is my short leg times √3. So I already have x, because I already have the √3. So my short leg, which is my 30 leg, is gonna be the 4. And my hypotenuse is gonna be the 4 times 2, which is 8. 45, 45, 90. If I have one of the side lengths, I have the other. And then this one is just the side lengths times √2. So I end up with 3 times √4, or 3 times 2. So that side length is 6. And then finally, the last one is a 30, 60, 90. And it looks like I have the hypotenuse. And the hypotenuse is double the short side length. So I'm going to divide this by 2 to get the short side length. 8 √3. And then the 60-degree side length is the short side length times another √3. So it becomes 8 times √9, or 8 times 3. So the short side length is 8 √3, and the long side length is 24. All right, and now we're into conversions. What we need to know is that pi radians is equal to 180 degrees. So if I have degrees, and I want to get the degrees to cancel out, I need to put the degrees of that conversion in the bottom and the radians in the top. And then I multiply straight across. So I end up with 48 pi over 180. And then I'm just going to do 48 divided by 180, math, enter, enter, and simplify that fraction. So it's 4 pi over 15. So if I have degrees, I want to put the 180 degrees in the bottom. Opposite places makes the degrees cancel out. And then when I multiply straight across, 330 times pi over 180, the degrees are canceling out. I'm just doing 330 divided by 180, math, enter, enter. And that's 11/6, so I get 11 pi over 6. For this next group, we're going to do the opposite. We've got the pi in the top, so to get rid of the pi, we'll put the pi in the bottom, which means the 180 degrees goes in the top. So I'm going to do 180 times 7 over 5. The pi's cancel out. So it just becomes 1260 divided by 5. So that's 252 degrees. So 5 pi, I want to cancel that out. So I'm going to put the pi in the bottom, which means the 180 goes on top. 180 times 5 is 900, and the pi's just cancel out. So this is 900 degrees. All right, now we're doing our long conversions. This is the last 4. All right, so 1200 degrees per hour to radians per minute. So 1200 degrees per hour. We want to change hours to minutes. So I'm going to put the hours in the opposite place so it cancels out, and the minutes in the bottom. And what I know about hours and minutes is 1 hour is 60 minutes. I got to make sure the numbers go right next to the right unit. And if I want to get rid of degrees, I got to put the degrees in the bottom. And I want it to become radians. And what I know is that 100 degrees is, 180 degrees is equal to pi radians. So what happens here is the degrees on the top cancels the degrees on the bottom, the hours on the bottom cancels the hours on the top, and we're just left with radians per minute, which is what we want. So I get 1200 times pi over 60 times 180. 1200 times pi. I'm just going to write that as a decimal. So it's about this. And if I divide that by this 10,800, I get 0.35, and that would be radians on the top is the only unit left per minute on the bottom. minute left. All right, 27 miles per hour into inches per second. So I want to get the hours to become seconds. You might have to do hours to minutes and then minutes to seconds, but I actually know that 1 hour is 3,600 seconds. So you could figure that out too. That's going to cancel out the hours. And then I want miles to go away. I don't know how many inches are in a mile, but I do know how many feet are in a mile. So 1 mile is 5,280 feet. And then I can make the feet go in the opposite place and change to inches. So I know that 1 foot is 12 inches. So what happens here is hours takes out hours, miles takes out miles, feet takes out feet, and we're left with inches per second. I'm just going to multiply 27 times 1 times 5,280 times 12. 27 times 1, 5,280, 12. All of the top numbers give me this. And then I'm multiplying the bottom numbers, which looks like it's just 360. And then I'm doing that top number divided by that bottom number. And that's inches per second. All right, these last two are your double ones. You're given some information here. So I'm given that I have a diameter of 30 inches. So if I want to find the circumference, because I need a revolution, which is the circumference, I'm going to do the radius. 2 pi times the radius. So that's 30 pi inches. And 1 circumference is the same thing as 1 revolution. So that gets me a revolution. All right, so we have 60 revolutions per minute, and we want miles per hour, which means I want the minutes to cancel out. So I'm going to put the minutes up top and the hours on the bottom. And I know that 60 minutes is 1 hour. That's going to get rid of the minutes. Now I'm at revolutions per hour. I like the per hour, but I don't like the revolutions. So I want to get rid of the revolutions. So that means I'm going to have to put a revolution in the bottom. Well, I know that 1 revolution is equal to 30 pi inches. So that gets me the revolutions to cancel out. Now I've got inches per hour, but I want miles per hour. So I got to get rid of the inches. I can't do inches to miles, I don't know that, but I can do inches to feet. And I know that 12 inches is 1 foot. So the inches will cancel out, and now I'm at feet per hour. So now when I get to miles, meaning I don't want feet, I want miles. 1 mile is 5,280 feet. Now I'm at miles on top, hours on the bottom, and that's what I want. So now I'm going to start my multiplication. So top numbers, 60 times 60 times 30 times pi. It's going to give me this big number. And on the bottom, 12 times 5,280. And now I'm doing top number divided by bottom number. And that's going to give me my miles per hour. All right, last one, I'm given that I have a radius of 8 inches, so I have 2 pi r. So my circumference is 16 pi inches, and 1 full circumference is 1 revolution, 1 circle. So that's my revolution. I have 5 feet per second. And I want to change that to revolutions per minute. So the first thing I'm going to do is I want to get rid of seconds. So I'm going to put them in opposite places to keep minutes on the bottom. And I know that 60 seconds is 1 minute. So that's going to cancel out the seconds. It's going to give me feet per minute. So I got the per minute. Now I need the revolutions, which means I want to get rid of the feet. So I need feet somewhere in the bottom. And I know that revolutions are in terms of inches, so I do want to get inches. And I know that 12 inches are in a foot. So that'll get rid of the feet, and it'll give me inches per minute. So I don't want inches per minute, but I do know that 1 revolution is equal to inches. So 1 revolution is 16 pi inches, which cancels out the inches and gives me revolutions on top and minutes on bottom. So now I'm ready to do the multiplication. Top numbers, 5 times 60 times 12. Over bottom numbers, 1 times 16 times pi. 50.27-ish. So I'm doing the top number divided by the bottom number, 71.62 revolutions per minute. Hopefully this explanation helps. If you need more review, there is an extra practice quiz review guide on the front table. I don't have a video explanation for that, but I do have an answer key with the work posted online. Quiz tomorrow.